want to do another example before we go to the homework. Is this the one I want to do? This one right here? Well, this is almost exactly what we talked about, but here it is. Let's see, can I make this bigger? Here it is in words. So you can see this is a good example of a quiz 2 problem where you pretend like you don't know that this is the first one. You're reading it and you're going to say to yourself, okay, is it giving me the population standard deviation? Is it giving me the sample standard deviation? Or is there no standard deviation? Well, you know this week is giving you the population standard deviation, but as I'm reading it, I want you to kind of soak it in as to, oh, okay, this is how I'm recognizing this one. You'll see the words. Also, I want you to realize what is the hypothesized mean being given to you and what is the sample mean. Because the sample mean and the hypothesized mean, you've got to recognize which is which. So here it goes. It says, boy, I gotta make this even bigger. There we go. See if this will work. Go ahead.
I have a quick question. So what's like the key identifier that it's two-tailed?
The key identifier is two-tail. That's the tough part too. That's the other tough part. Is it two-tail or one-tail? The key identifier is usually you'll see nothing about it being greater than or less than or at least or at most. None of those words would be there. And usually the word for the researcher part will say, and they won't think it's different or differs from. The word differ means it could go either way. That's kind of a key indicator is two-tail also.
Okay, thank you.
So let's see what this says. A research analyst disputes a trade group's prediction that back-to-school spending will average $606.40 per family this year. Okay, so right there, that's the hypothesized mean. Because the researcher is trying to dispute that, saying, no, I don't think it is $606.40. We haven't collected the data yet, but you just read the hypothesized mean value. The part on the right for both of these are always the same number. You never put the sample number up here. This is the same number as always on the null and the alternative. The exact same number, and it's the hypothesized number. In this case, 606.40. She believes that the average back-to-school spending will differ. Everybody see that? Right there, it's just telling you right there, that's two-tail. Let me read it though, one-tail. She believes that the average back-to-school spending is greater than, now you know it's one-tail. Or she believes the back-to-school spending is less than, now you know it's one-tail. But this one says, she believes the average back-to-school spending will differ from this amount of 606.40. You get it? Two-tail. So you made it through one stumble. Now you're still trying to figure out which type of problem do I have here, but you know it's two-tail at this point, and you know the hypothesized number is 606.40. She decided to conduct a test on the basic random sample of 30 households. We just have our sample size. Square root of 30 is in this problem, because we got a mean. With school-aged children, she calculates the sample mean at 622.85. Now we've been given the sample mean. Remember, what we've just been given is not part of the hypothesis. It's that number right there in the calculation on the left side of the numerator. The sample result is that number. Given to us in words. Let me read it again. She calculates the sample mean to be 622.85. Now look at how far away from it is from 606. Yeah, it's, what is that? 12, 10, 18, I don't know, what is that, 12? 14, 15, $16 away approximately. But you can't tell. 16 seems like a lot, but you're not sure it's a lot. The sample is not that big. How big is it, 30? It's only 30, it's not 100. So we can't tell by just looking at it without calculating anything if that is significant enough to say, no, it's not 606. We can't tell yet. We got to calculate this test statistic. We got to plug it into here. We got to get a p-value, and we got to see if it's less than whatever the significance is. Let's see what the significance is. She also believes that the back-to-school spending is normally distributed with a population standard deviation of $65. Boom! Those words right there tell us to go to this first formula, which you know in the homework's going to be this one. That's all that's on the homework this week is just the first one. But there is an example, like a test question, how you just determined it's the first one. She believes that the population standard deviation is $65. You've been given the population standard deviation, not the samples and not none. It is definitely standard deviation and it's the populations. Well, you're sicker than I am.
It's like one of those coughs, you know,
that's
that
how it started on me.
you're not sick, but it's just a cough.
You guys, it was the worst thing I've ever been through. It was the worst thing I've ever been through. I'm now in physical therapy because it all went to my neck, and I'm on a whole bunch of pain pills right now. I don't know if you can tell. My eyesight's blurry. I can't even see anything. That's okay. I just did though. Population standard 65. She wants to conduct this test at 5% significance. There it is. We have our significance. We know we're compared to 5%. I'm not even going to erase this. We have our significance. We have our standard deviation. We got our sample size. We got our sample mean. We got the hypothesized mean. We can calculate. Before I show you the answer, I'm just going to do it in my head real quick. Ready? Where's the sample mean? 622.85 minus 606.40 divided by $65 over the square root of 30. There it is. That setup is where the points are. Did you guys remember that when you took the first quiz? I wasn't here. Did you remember the setups where most of the points are?
Yeah.
And everybody showed the numbers in the equation, the setup, so I could give you all as much points as possible? Good. All right. That's the same thing for quiz 2. The setup of this test statistic that I just said out loud is where the points are. That's where the points are. Let's see, that would be,
It's 1
that's probably about 1 1/4 points right there just in the setup on a 3-point or 2.5 point problem. So here we go now. We set it up. We calculate the test statistic. Here's our null hypothesis equals 606.40. Not equals the alternative, 606.40. We got it. We know it's two-tailed. We're going to calculate, where is it? Here we go. We calculate 622.85 minus 606.40 divided by blah, 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 1.39. Here we go. Where's the eraser? Is that positive or negative? Uh-oh, we're not even using that equation. We're using this one. 1.39. Is that correct? 1.39 equals 1 minus NORM dot DIST, parentheses, 1.39, comma, 0, comma, 1, comma, 1, parentheses. And say it again? Oh, shoot. I thought you were telling me what to do next. Someone tell me what to do after that. Multiply by 2, exactly. Exactly. Because it's two-tailed. Let's do it. Hang on, I gotta plug it in. Hang on, where's my Excel? 1.39, right? Here we go. Equals, what is it? 1 minus? 1 minus NORM dot DIST, parentheses, positive 1.39, correct? Positive 1.39, comma, 0, comma, 1, comma, 1. Our p-value is 0.082264, but no, we got one more step. Hang on, equals, what cell's that? D6? D6 times 2 because it's two-tailed. Our p-value is 0.1645, almost 16.5%. What is it we're comparing the 16.5% to? Which is how much? 5%. Is 16.5% more than or less than 5%? Can you reject or cannot reject?
Cannot reject.
You got it. Oh my God, this homework's too easy. Oh, what are we doing here? What? Who's done? Oh, you're done with the homework? Swear. Oh, shoot. That would have been good. Absolutely. Let's keep going and see if they said the same thing here. They don't show you the Excel equation. They just show you that they're using the chart still on this book. Using the chart. We're using the Excel. We're not using the Z chart. 0.0823, but then we got to multiply times 2 because it's two-tailed. 0.1646. Are you ready? And your answer should say, it should look like this. What is that? Since our p-value of 0.16, give me the rest, I can't see it.
4.5.
Thank you, 4.5 is greater than, this is how you write your answer, it's greater than the significance, you can abbreviate, significance 0.05 or 5%, whatever you want to write there. Let's see, since our p-value is greater than our significance, I need the numbers, we can not reject. It's all about the null. The null hypothesis. Boom. There's your answer. You're showing all your work. You're showing this. you're showing, you've got your p-value, I can see you calculated p-value, I can see right here that you're comparing it to the significance, and you're telling me you can't reject it.